At this time, we'll go ahead and welcome the team from Alabama as the last presenters. The University of Alabama team, Team Saban, is represented here by Miss Elizabeth and Miss Lauren Weiss, and their industry mentors, Mr. Sergio Claude. They will be presenting today on the implementation of a bus transit system along the Independence in Havana, Cuba, and its positive impact on quality of life and the environment. Once they are done presenting, we will move on to lunch, and where the judges can deliberate on the top teams, and we'll come back and present that after lunch.
Good afternoon, ladies and gentlemen. My name is Lauren Weiss.
And I'm Elizabeth Hartzog.
And we're seniors at the University of Alabama, both studying civil and environmental engineering. We would like to extend a thank you to our esteemed judges and also to our hosting committees for giving us the opportunity to come here today to talk more about our experience and about our research. We're also thrilled to be here representing Alabama for the first time.
So before we get into the logistics of our design, we kind of wanted to give you a background on where we felt confident enough to enter this. So in May of 2016, Lauren, myself, and 5 other students from the University of Alabama had the privilege to go down and study at CUHI, which is Havana's engineering university. We were led by 2 of our professors, and we also were taught lectures by the CUHI professors. And we spent many hours in the classroom as well as observing transportation issues within Havana, and so with that we felt that a bus rapid transit system was an urgent need for the public.
So as our objective was to establish a bus rapid transit system in Havana, we had to kind of determine where exactly the most need for that was. And so on this map, I've highlighted in red and the street in black. These are routes that appeared to be commuter routes that were heavily traveled in and out of Havana. And the route in black is the one that we chose to utilize for our feasibility study today. The route is La Avenida de la Independencia. And while we were in Cuba, we took part of this road to get to CUHI, and so we observed some public transportation issues from the buses and from the current infrastructure, the roadways, and this is why it was the road that we chose. As we began gathering data and really digging into this issue, we decided that there were some assumptions and considerations we needed to establish that would kind of guide our data collection. First of all, a lot of the data we were looking for, car ownership and car registration rates, or the amount of people that own those cars in Cuba, was not really readily available, except for maybe in the year 2005, which was a lot farther back than we wanted to go. So we did some interpolating and some estimation for some of that data, and we also looked at 3 other areas that have already established existing BRT systems, and we had to do a little bit of estimation for those same data sets as well. And we also decided to work within Havana's current infrastructure. That way we would not be building any new roads. We would be kind of building our BRT systems into the road, and it would keep costs down. And despite the despite establishing a BRT system as a mode of public transportation, we also recognize that people have their personal preferences for transportation, and so this may affect our ridership rates, which we will discuss later in the presentation.
Prior to collecting data, we had to determine how our design would fit into the existing infrastructure. And this is an accurate depiction of what we want to design. It has the bus-only lanes with the loading dock in the center of the lanes. And this is a more realistic picture. It has the center loaded lane with the 2 lanes and the projected entrance of passengers by crossing the crosswalk and entering through a prepaid entry to the terminal, and then they will then proceed to the elevated loading dock that is level with the bus to allow for a more time-efficient entry and exit of the bus.
The most important aspect of a BRT system is that it is incredibly efficient, and it's important to maintain a strict schedule and to maintain that efficiency. Otherwise, it's just another bus system. And so in order to abide by this efficiency, we decided to make the length of stops proportional to the population of an area. So if there was a large neighborhood around a stop that we are going to implement, or there were many shops, or there's a lot of economic activity, places where people would be getting on and off the bus, those stops would be longer to account for this. And then stops that were in lesser populated areas would be shorter because there would be less people.
And in order to establish that efficiency, we decided that the passengers would need to know of the bus arrival, and so we decided that sensors would be installed in the road with a 1-minute arrival countdown at the stop so they could be prepared to enter and exit the bus in an efficient manner.
So this is a map of our route that we decided to implement along La Avenida de la Independencia. The left side is the southernmost point of the route, and the right side would be the northernmost point. So we have 11 stops along this route, which ends up being about 6 miles approximately in length. On the far left side is the northernmost point of the route, and in order to, like we were saying, increase efficiency, there's already a roundabout built into this area, so we decided our route, the bus on our route would simply go up to the top, stop, and then go around the roundabout to continue back down. And on the right picture, that's where our BRT system, our BRT corridor would end in the southernmost point, and we felt that it would be not too much of a challenge structurally to implement a roundabout there as well to allow for the buses to turn around. And the center picture is just a zoomed in example of one of the places where we added a stop. As you can see, well, it was difficult for us to really find any data about specific areas, like the population of neighborhoods or anything of that sort. So based on what we were able to see on Google Maps, it looks as if it would be a very populated area. So obviously, if we were going to implement this further, a more detailed analysis would need to be done at a later date, probably in conjunction with the Cuban government. So the next step in analyzing the implementation of this system was to attempt to estimate the ridership that we may see. And so we have an equation, a basic equation, to kind of come up with a number for that expected ridership. The best way that I could think to do this was to compare Havana, to the system we would like to implement, to several already otherwise implemented systems in Miami-Dade County. There are actually, I think, 8 corridors around the city and downtown area, and Curitiba, Brazil, and Bogota, Colombia. Obviously, the populations of these places differ slightly, and the number of registered cars is also, as you can see, quite higher. So we wanted to account for the differences in car registration, as you know, that's not, car ownership is not as common in Cuba. So we came up with a ratio of cars per person and divided each of those by Cuba's cars per person to kind of come up with a factor. And we were able to find BRT ridership as a percent of population from the Miami-Dade County, Curitiba, and Bogota in our research. And so we calculated those numbers and then multiplied that by the Cuban population, and we're able to come up with an average BRT ridership. So obviously this number could be, this number really depends on the population of Havana as a whole. So this would not be like too much indicative of the specific route we chose, but if they were to implement several routes, the ones I highlighted in red earlier, that would be, that number there would be the total ridership that would occur along all of those corridors. As we analyzed the effectiveness of this situation, or of this system, excuse me, it was also important for us to study the specific environmental and economic impacts that the implementation would have on the people and also on the area.
As shown in the previous slides on the projector ridership, there is a large number that we have expected to utilize the bus rapid transit system. Having more passengers utilizing the system results in less cars on the road, which results in an increase in air quality. An increase in air quality is better for the public all around, as there are less pollutants in the air due to the lead-fueled cars that monopolize Havana.
Again, it was difficult to discover very costs, data for costs that we could apply specifically to Cuba, because costs for manual labor and costs for materials, costs for all sorts of other things that would be included in the construction cost would be quite different, I believe. But we came up with a very rough estimation to kind of show that we believe would be possible to implement. So from some data that we found from the National Cooperative Highway Research Program in the United States, they had done an example study, and their total construction cost was about $25 million, but their route length was 8 miles, so we found the cost per mile for that. And then we found the cost per station, as you can see there, because they had many more stations along their route than we wanted to implement. We used the US government's inflation calculator to kind of put that in 2017 numbers, just to get a more accurate number for today's standards. And from there, we multiplied both of those by the route length that we had chosen and the total number of stations, respectively, and came up with a total cost of $21 million, which I believe could possibly be lower, based on all of those things I'd mentioned before about just the cost of labor and such. Well, after considering all of these factors that we presented today, we believe that it would be feasible to implement a bus rapid transit system in Havana. Further research would definitely need to be done to confirm what we believe we found. We think too, obviously, certain financial and structural steps would need to be taken to make this a more attainable goal for the future. But we believe it would be a worthwhile enterprise, as it would improve the quality of life and hopefully the economic prosperity of the people who reside in Havana. Thank you.